So, hello everyone, I Raghavendra Singh welcomes you all in the another video of database management system often known as DBMS. And the date is 25th of April 2026, the day I am recording at 11:40 p.m. Why I am saying all of this? So today we are going to start some topics of DBMS. So basically I am going to start from unit 4 in my syllabus. Although I will cover all units, I think this is my first video. Although you will get all topics video. Right now I have understood very well unit 4 and 5, so I'm going to cover these two units in this video. So I hope this all recording, yeah. So I hope everything visible. So what is DBMS? You all will be knowing that database. Basically this introductory part is a part of unit 1. I'm going to start with unit 4. So basically database in any college, any university, any company, we have to maintain some data so that if we want to know anything about anyone, we can search on this database and we can get the information. So I'm going to start some topics. First topic, there are some topics. Suppose problem caused by redundancy, decomposition problem related to decomposition, reasoning about FDS, first, second, third normal forms, BCNF any boys code normal form, fourth normal form, lossless joint decomposition, dependency preserving decomposition, schema refinement, and database design, multi-value dependencies. So these are the topics in unit 4 which we are going to cover. So first topic is problem caused by redundancy. Problem caused by redundancy. Okay. So basically what is redundancy? Redundancy is nothing but the repetition of same data. Repetition of same data is called redundancy. So basically what are the problems which we face if data is repeating again and again in the system? So there are some problems which we face. First is as I told you, redundancy means storing the same data multiple times. Okay, storing the same data multiple times is known as redundancy. Okay. This leads to anomalies. Anomalies. Now what is anomalies? It's nothing but the new word. Anomalies means problems. Okay, just simple problems that cannot be solved, I can say. Okay, anomaly is just a kind of problem, nothing else. Means kind of question or something like that. So first is, there are some anomalies. First is update anomaly. So first is update anomaly. So what is update anomaly? So basically update anomaly is nothing but if You want to change a student address in one row but forget to change it in another. The data becomes inconsistent. Okay, update anomaly. Simple. We have a database of any university and we want to change the address of a student. Okay, we want to change the address of a student. So as you all know, the database, from database all departments of college are connected, of departments of the universities are connected. If we change the database in the school level but we didn't change in the university level, so it will create inconsistency. Okay, inconsistency. I hope you are getting what I'm trying to saying. So that's why we need to create a database. If we change anything in database, the source, main source of that data, so the information will be changed everywhere. Okay, so first was update anomaly, and second is insertion anomaly, and second is insertion anomaly. Okay, so insertion anomaly, nothing but you can't add new course unless a student enrolls in it because the table requires both. Okay, what I'm trying to say is you can't add a new course. You can't add new course. Obviously, you can't add a new course unless a student enrolls in it. I'm trying to say, if suppose Ram wants to get admission in the BTech in robotics, so how can we create course if there are 40 students? Do not anyone wants to take robotics? Like, we do not need to introduce a robotics course if not anyone is interested. If Ram is interested to do BTech in robotics, then only we can introduce the robotics, right? I hope you are getting what I'm trying to say. So basically table requires both the student name and the, so table requires both the student name and the course also. I hope you have understood. Now I know थोड़ा डिस्टर्बेंस हो रहा होगा just because कूलर चल रहा है, अब गर्मी भी बहुत ज़्यादा है, that's why I can't do anything on it. Please try to manage. So next is deletion anomaly. Deletion anomaly. So deletion anomaly. Okay. So what is deletion? If you delete the only student in course, you accidentally delete the information about the course itself. Obviously, if you delete student, then you automatically delete course. Okay, auto. So how? Simple. If we delete the student, means we have deleted Ram, and Ram was the only person who was doing BTech in robotics. If we delete the student Ram, then course will be also automatically deleted because there was only one person who was enrolled in robotics under graduation. Okay, I hope you have understood. If we are going to delete this, then this course will be automatically deleted. Okay, now let's move on to the, I hope this all is visible. Now let's move on to the decomposition. Second topic is decomposition. जैसे कि नाम से ही you all will be getting idea what is decomposition. Decomposition is nothing but dividing. Suppose we have a very big table, and we have to divide according to each column so that the data can be more clear and more understandable. Okay, yeah. So decomposition, this is the cure for redundancy. Okay, so basically this is मतलब redundancy बचने के लिए हम decomposition यूज़ करते हैं. हम decomposition क्या होता है बता चुका हूँ. तो decomposition से हमें डाटा को स्प्लिट कर देते हैं so that redundancy या फिर repetition कम होता है. Okay, so basically this is the cure of the cure means alternative way to be saved from redundancy. Oh my god, it's ultimately cure of redundancy. Okay, yeah. So it means breaking one large messy table into two or more smaller cleaner tables. Okay, simple large tables into two more tables, two or more than two tables. Okay, now problem related to decomposition. Problem related to decomposition. So basically there are some problems related to decomposition. So if you decompose a table carelessly, you might face two major issues. Carelessly, okay? If we decompose, what is decomposition? Splitting the large tables. So if you decompose tables carelessly, then we might face two major issues. First issue is loss of data. First is loss of data, and second is loss of rules. Loss of rules. Now what is loss of data and loss of rules? So basically loss of data is you can't get the original information back. Okay, simple. If we want to decompose the student table name, so basically we will be having so many information about the student, like address, phone number, email ID, father mobile number, the qualification which he has done, and this all information we will be having. If we decompose the table, suppose we want to make a separate column for marks of the students in the in the all semesters, so we might have loss of data. Okay, so the loss of data means which we can't recover. Okay, the data which we can't recover. I hope this all is visible. Yeah. And loss of rules means you lose the ability to check if the data follows certain rules, like follows certain rules. What are the certain rules? That is functional dependency. What is functional dependency? I will also discuss about this. Without joining all tables back together. Functional dependency is nothing but joining of tables back together. Okay, I hope you have understood. And now next topic is reasoning about functional dependency. Reasoning about functional dependency. So what is reasoning about functional dependency? Basically, so and functional dependency written as x tends to y. Okay, simply means, what does it mean? If you know the value of x, suppose x is 2, so if we will put the value of x in place of in the value of 2 in place of x, then we will get the value of y. So okay, if you know the value of x, then I can definitely tell you the value of y. I hope you all have understood. Now let's move on to the normal forms. So there are some normal forms. Normal form. So first normal form. What is first normal form? It is nothing but no multi-valued function. First, no multi-valued function. What is multi-valued? Non-multi-valued? I will let you know. No multi-valued function. Okay. Every cell in your table must contain only one single value. Every cell in table must contain only single value. Single value must contain only single value. Simple means you can't have red, blue in same table. Okay, only no multiple means multi-value means more than two values in one table. Simple. Now let's move on to the second normal form. Second normal form. So basically, for second normal form, first of all, it should be first normal form. To be second normal form, it should be first normal form. First normal form, which are the first normal form? First of all, multi-valued. Okay. Plus no partial dependency. Plus no partial dependency. What is partial dependency? I will let you know. No partial dependency. Okay. Yeah. So let me remove the laptop. Just wait a second. I'm not able to write properly. Yeah. Now it is okay. So no partial dependency, and this and if I want to say in simple words, then it is, if your primary key is made of two parts A and B, every other column must depend on both A and B, not just one of them. Simple. If your primary key, I can also write it as PK, and next time I will write only PK because it's too long. If your primary key is A and B, then every column must depend on A and B both. Okay, A and B both. Remember, A and B both. Not only in not only in A and B, A or B. Okay, I hope you are getting what I am saying. Now third normal form. So what is third normal form? First of all, it must be two normal form. Okay, must be two normal form. Plus no transitive, plus no transitive dependency plus no. Remember, these are the conditions which you have to remember while a question will be asked. Simple, this is the functional dependency. Let us know, is this 3NF, 2NF or 1NF. For this you have to remember these conditions. No transitive dependency, no transitive dependency. So what is transitive dependency? You all know, you have done this in class 12. Transitive dependency means A tends to B, A depends to B, B depends to C, then A should also depends to C. This is transitive dependency. Okay, so it should be no transitive dependency. So in the simple words, if I were to say, then a non-key column should not depend on another non-key column. Simple, a non-key column should not depend on other non-key column. Okay, I hope you all have understood. Everything, hashtag everything should directly depend directly on the prime key. Depend on prime key. Okay, yeah. Let's move on to the next. Next is 8th topic, that is BCNF. So BCNF, very simple, voice chord normal form. Voice chord normal form. So what is voice chord normal form? So it is nothing but the slighter. Like slighter means thoda sa strict version of strict version of third normal form. Okay. So what do I mean? As you know, what was the condition of third normal form? First of all, it should be 2NF plus it should be no transitive dependency. Now what is this? Basically, for every dependency, X tends to Y. For every dependency, so for every dependency, X tends to Y. Okay, X must be super key. So here X must be super key. S key I am writing. S must be super key. This closes small loopholes that 3NF sometimes misses. Super key. So what happens if X is super key? This close small loopholes. This close small loopholes which sometimes 3NF sometimes misses. Now fourth normal form. Now ninth topic is fourth normal form. So what is fourth normal form? As you know, first of all, it should be must be BCNF plus no multi-value dependencies. No multi-value dependencies. Okay. Yes, it's no multi-value dependency. I hope this all is recording. Hmm. So what is for NF? So a table should store two independent many-to-many relationship. A table should not store, remember, should not store two independent many-to-many relationship. Two independent many-to-many relationship. Now what is many-to-many relationship? So you know, you have done this in class 12. So what is many-to-many? Suppose we will be given a function like this, a b c d, and this is 1 2 3. So a has 1, a belongs to 1, b, a also belongs to 3, d belongs to 1, d also belongs to 2, d also belongs to 1. So this is many-to-many relationship. So in this written, a table should not store two independent many-to-many relationship. Obviously, if there will be many-to-many relationship, then it will create a redundancy. Okay. Now let's move on to the lossless joint decomposition. 10th topic is lossless joint decomposition. Lossless joint decomposition. Okay. Lossless joint decomposition. When you join the smaller table back together, you must get the exact same data as the original table. Simple. When you join a smaller table back together, so we should get the same data as it was before decomposition. Okay, getting my point? Basically, lossless means we do not have any kind of redundancy after decomposing or after lossless join. What is join? Join means merging two tables to get information. Okay, I will let you know what is join. So smaller must get exact